Hello everyone. Myself, Priyadarshani, Assistant Professor, working in Triple Department of RMD Engineering College. Today we are going to see a topic from the subject Basic Electrical, Electronics and Measurement Engineering. So the topic is from the Unit 1, the first unit, Electrical Circuit Analysis. So let's move on to the topic. So in this session, we are going to discuss about the theorems, especially about the superposition theorem. For the superposition theorems, and not only for the superposition theorems, for all the theorems, the basic technique which we are going to use, which is source transformation technique. So first we will have a look on this technique and then we will move to the theorem. Okay, let's go to the topic. So, source transformation technique. So, what is the meaning of source transformation? Okay. The source transformation is nothing but we are going to transform a source, that is a voltage source, to a current source, or a current source to a voltage source. Okay, the main two sources are, one is the voltage source, another one is going to be the current source. Okay. So the transformation is nothing but we are going to transform one source towards another source. So this is an important technique in solving the theorems. Okay. So what kind? How we are going to transform? So that is the basic thing. So first, uh, take a look on this circuit. So here we are having a voltage source. In series to this voltage source, we are having a resistance. Right. And this has to be transformed to a corresponding current source. Okay, so we know the basic formula. So what is the basic or overall? The important rule is nothing but Ohm's law. So based on this Ohm's law, this voltage source will be converted into the current source. The resistance, which is series to the voltage source, will be coming to the parallel. Okay, so we know what is Ohm's law. V is equal to IR, or I is equal to what? V by R. So like that we can say, right? So here, based on that rule, this voltage source and by using this resistance, we will be converting that into a current source. Okay, so V by R. That will give you the I. This resistance will be, which is in series with the voltage source, will be coming in parallel with the current source. It is the same, that is, it's vice versa. If any current source is given, our resistance is parallel with that, this can be converted into an equivalent voltage source, and this resistance which is in parallel, it will be coming to the series in voltage source. Okay. So like this, we can use the source transformation technique. Okay, so to have a clear idea, so let's we move on to the problems. Okay, the next is, see, determine the equivalent voltage source for the given current source. Okay, so a current source has been given here. So for this, we have to find out an equivalent voltage source. How they are using. So see, a 5 amps current source, okay, it is in parallel with a resistance of 5 ohms. Okay, so this has to be converted into a voltage source. Okay, so now this 5 amps and this 5 ohms. So this two values has been used. So what is our formula? We know according to the Ohm's law, V is equal to what? I into R. So this is my current and this is my R value. So I into R, I is 5 and this is also 5. So 25. Okay. So 25 volt. Then the resistance which is in parallel with the 5 amps, it is in connected in series, that is 5 ohms. Okay. So similarly, vice versa also we can do. Okay. So whichever current source is there, the parallel resistance has to be used to convert a current source into a voltage source. Right. The next thing, see here. Determine the equivalent current source for the given voltage source. Okay. So here a voltage source has been given and this has to be converted into a equivalent current source. How to convert? What is our first rule? So we have to see are any resistance is there in series with the voltage source. So first point. So here the series resistance is what? 30 ohms. So how to convert this voltage source into a current source? I is equal to what? V by R. So 50 divided by 30, that is nothing but 1.66. So I value is 1.66. This current value, that is this resistance value, whichever it is in series with the voltage, that is coming in parallel. So 1.66 amps parallel with the resistance 30 ohms. Okay, so this now the voltage source has been converted into a current source. Okay, right. So we saw two problems or two examples for the transformation. So next we are moving to the theorems. So in this session we are going to see a main theorem, a foremost theorem or the first theorem, that is superposition theorem. Okay. So we are going to see how to solve a problem on the superposition theorem. Okay, right. First rule. So for any theorems, okay, the statement, what the theorem states, okay, where to use the theorem, how to use the theorem, everything will be given in a statement. Okay. So here what they are saying, see here, the superposition theorem. See, the superposition theorem states what is it, it is stating, that is in any linear network, the important point is the network should be a what? A linear network containing two or more sources. Okay, where we can able to use this theorem? It should have two or more sources. The main point is it should be a linear network and then it should have two or more sources. The response in any element, the response can be in term of a current or in term of a voltage in any element is equal to the algebraic sum, total of the responses caused by the individual sources acting alone, while the other sources are non-operative. Okay. So that is what they are saying. While considering the effect of individual sources, other ideal voltage sources and ideal current sources in the network are replaced by short circuit and open circuit across the terminals. Okay, so here what the statement says, what they are saying, in any linear network we are having, it should have two or more sources. Then if we are finding any response, the response can be of current or a voltage in any element, or a resistance, okay, or in any element. Okay, it is the algebraic sum, it is equal to the algebraic sum of the responses caused by the individual sources. That is, one source should act at a particular time. The other source should be what? Non-operative. Okay. If it is a voltage source, the corresponding step to be done, or if it is a current source, we have to do the corresponding step. Okay. Then only one source has to be acted at a particular time. So at the time, the response has to be measured, okay, or calculated, and then what we have to take the algebraic sum. Okay. This theorem is valid only for what systems? Linear systems. So what are the two main points? One is this can be used only for a linear system. Another thing, it should have what sources? Two or more sources should be there. Okay. Right. The next thing, how we are going to remove. Okay, so they are saying we have to remove one source, like that they are saying, but how to remove? So here they are saying, suppose in that circuit, if I'm having a current source, right, it should be what? Open circuited. in the circuit, if I am having what source, see this point, current source, it should be what? Open circuited. Okay. The second point, what they are saying is, if I am having voltage source, if I want to remove, I should made what? Short circuit. The 2 points are there. One is, if I'm having a current source, it has to be open circuited. If I'm having a voltage source, it should be what? Short circuited. Circuiting the terminals, and this is open circuiting the terminals. Just it is opened. Okay. So like this, I have to do in my circuit while I'm having two or more sources. Okay. So now we are moving to the problem. First problem, and then first we will see what is short circuit and open circuit. What is the meaning of short circuiting? See here, this is my terminal 1. For example, I am saying this is my first terminal 1 and this is terminal 2. If I am short circuiting, I am taking a conductor, a wire, I am connecting the two terminals just like this. Okay, right? So if I am connecting like this, what will happen? It has been short circuited. Short circuited means what will happen? The current will be very high and the voltage is going to be what? Zero. Okay. If I am touching the two terminals simply with a conductor, what will happen? Definitely a spark will come. Yes. So like that, it is short circuited and the voltage is going to be zero. What is open circuited? The terminals are kept open. There is no connection between the two terminals. So that is the point. If there is no connection between the two terminals, that is called as what? Open circuited. Open circuited means what will happen? Current is going to be zero. There is no current in that path. It is not a closed path. It is an open path. Okay, so these are the two things that is very important in the circuit analysis. One is short circuiting, another one is open circuiting. Open circuiting means there is no connection. Short circuiting means we are shorting the terminals or we are connecting the terminals simply by a conductor. It is not having a specific or equivalent resistance. Okay, right. We will have an idea or a look into this problem. So definitely we can able to understand what is superposition theorem. So see here, find the current passing through the 3 ohms resistor. So where is my 3 ohms resistor? Here it is my 3 ohms resistor. What they are saying, by using what theorem? Using superposition theorem. Okay, you find out the current passing through the 3 ohms resistor, right? So whenever they have given any problem like this, first we have to look at the circuit, how to analyze the circuit. Okay, so it is a circuit they have given. So how many sources are present? Two sources are there. One is going to be an voltage source, another one is going to be a current source. So especially they have said we have to use what theorem? Superposition theorem. Automatically they have said. So what is superposition theorem? Already we know. So if I want to find out a response, means what I have to do? I have to remove, I have to consider only one source and then other source has to be non-operative. So that is my step. Yes. So first I'm going to consider one source. Let it be a voltage source. Voltage source, if I'm going to consider, means I have to remove the current source. Okay. So already I know if I am removing the current source means what I have to do. I have to open circuit the terminals. Okay. If I am removing the voltage source means I have to short circuit. If I am removing the current source means I have to open circuit. Okay. Step 1 is considering the voltage source. Okay. So step by step always we have to do. So first step 1. What is my step 1? I am considering only the one source, that is my voltage source. I am going to remove the current source. How to remove the current source? It has to be open circuited. Okay, the terminals are open circuited. Now I am going to find out the current across the 3 ohms resistor. Okay, so see here, I have given in the statement itself, 5 amp source has been what? Open circuited. Okay, so now you see. Now I have to find out the current across the 3 ohms resistor. So my circuit has been converted like this. So this is kept open. So how to find out the current across this 3 ohms resistor. So now the same thing, like what Ohm's law we can go. So see here, a loop has been given. Okay, I'm going to find out the current alone. So here the voltage is going to be, what is the voltage value? 20. What are the resistance to be considered? 5 ohms and 3 ohms. Why I am not taking this 10 ohms means definitely there is no path. The path is not completed for this 10 ohms. There won't be any flow of current through this 10 ohms. So only the 5 ohms and the 3 ohms are going to be an active resistance, right? So how to find out the current? I is equal to what? What is I is equal to what? V by R. So V R. These two resistance are considered to be connected in series. Why it is considered to be connected in series? We know the rule. How the current has been divided. See, if the current is coming like this, at this point it is going to get divided. Yes, we know this. But since there is no path, so definitely the current is not going to flow over there. It is not going to complete the path. So the same current is going to flow through this 5 ohms and the 3 ohms. So if the same current is flowing means these two resistance are what? It is connected in series. Okay. So this total, what is R equivalent? R1 plus R2. So 5 plus 3 is going to be 8. So 20 divided by 8 is going to be 2.5 amps. So what is the current across the 3 ohms resistance due to the 20 volt source is 2.5 amps. Can you able to understand this? So here well, you can have a doubt that why we are not considering this 10 ohms. So always we have to consider any resistance if the resistance, that is it is connected in a closed path. So definitely the current is going to flow means what? There is no complete path for that. Okay. So the current is not going to get divided over there. So same current has been flowing. So I'm considering 5 ohms and 3 ohms. So what is the current? 2.5 amps. So first response I have obtained. So the next, what is the second? 5 amp source is has been acting alone. I'm removing what? Voltage source. So how to remove the voltage source? It has to be short circuited. See here, I have removed this voltage source and this terminal has been shorted. Okay, that's all. The same again, I should consider the current across this 3 ohms resistor due to the what? 5 amps current source. Yes, how to find and which rule I can able to use. Okay, so definitely what kind of rule I can go? Current division rule, because these two resistance are connected in parallel, and definitely if the resistance are connected in parallel, if I am adding a current source also, I can definitely go for what rule? Current division rule. So the current across, right, the 3 ohms resistor. Okay, how to find out this? So total current. So what is the formula? The total current into, right, the opposite resistance, which is the resistance which is opposite to 3 ohms is 5 ohms. Opposite resistance by total resistance. What is my total resistance? 5 plus 3. Okay. So 5 plus 3 is going to be what? 8. So 5 into 5 by 8. Answer is what? 3.125 amps. This is the current flowing through the 3 ohms resistor only due to 5 amps. Okay. So see here, the current, what we are going to find out, the current across or due to 5 amp source, that is across what? 3 ohms resistor. How we are finding out? The voltage source has been what? Short circuited. Okay. So then we are using the current division rule, and then 5 into 5 divided by 8. Answer is 3.15 amps. What is the last thing? Total current, we have to add the responses. If I am adding both the responses due to the voltage source as well as due to the current source, answer is 5.625 amps. So this is the current flowing through 3 ohms resistor due to both the sources. That is, we have found out using what? Superposition theorem. Okay. So the next problem we can see is the same thing. Uh, That is, find the current across the 8 ohms resistor by using what theorem? Again, the superposition theorem. So here, how many sources are there? Two sources. One is the voltage source, another one is going to be the current source. Here also we are using the same principle. So first we have to consider only one source and we have to remove the other source. Okay. See here what they have done. So we have open circuited the current source, this 5 amps, and only we have considered this 10 volt alone. Okay. So only time we are considering this 10 volt source, so this loop and this loop we are going to consider, right? So after that, what we can able to do? The current through the 8 ohms resistor. So we can go for what analysis? Mesh analysis or that what resistance reduction method also we can able to do, and by that we can find out the current across the 8 ohms resistor is 0.588 amps. Similarly, if I am considering only the 5 amp source alone, if I then I have to short circuit this 10 volt. Okay. So then what we can do? Again, we can go for what rule? The current division rule or reduction method. Okay. So for that reduction method, we are going to reduce the circuit. See here, this 2 ohms and 4 ohms are to be connected in what? Parallel only, because here the current is getting divided. Yeah. So what is the formula for the R equivalent in parallel? R1 into R2 by R1 plus R2. So 2 into 4 by 2 plus 4. So 8 divided by 6 is 1.33. Okay. And then these two resistance are going to be in series. So 9.33. So 9.33 in, and it is parallel with what? 2 ohms. So again we can go for what rule? Current division rule. Opposite resistance into summation of the two resistance. The answer is minus 0. Because the current direction is in opposite direction. So minus 0.8824 amps. So if I am adding both the things, my answer is minus 0.2942 amps. Okay. So thank you everyone.